Hi people, um, and hi, this is Samyukta here, and I'll be visualizing some data. Um, I'm also participating in the commonlit student evaluation Kaggle competition, and I have in this competition I am given the student essays and also the prompt essay IDs, and I have to give them like predict what would be the future scores for the essay. Like by score, I mean the content score and the wording score, and so in the I have made a few videos also to display how I clean my data and how I have created new features using the present features, and I have handled missing values and replaced some of the values with some constants, and using feature engineering I have inserted a boolean feature as well. In this last column you can see there's a pass. I have tried to develop this feature using the content and the wording scores and the student ID. And in this video I'll be showing how to visualize my data and how I'll be using statistical data analysis um, to um, to learn about my features and how the data is distributed. Mm. So I'm using the matplotlib library in this and as well as sklearn and pandas for visualizing my data. Here you can see there's a bar plot, and this bar plot shows the content score, how is it distributed, and that there are many variables which are negative, falls in the negative domain in the content score, and there are very few positive variables which are, and the highest comes to 3.2 plus over here in the content score. So based on that we can actually um, scale our data or use the min-mask standard scalar to keep 1 and 0 while evaluating the content score and developing the machine learning model, predictive model. And some more improvements for this bar chart is I wanted to include statistical lines as well, and I have used some kind of colors and also the line graphs and the bar dashed lines to see where is the actual line. See, you can see here it is till 3.2. Now you can see exactly it is touching till 3 point, like almost approximately till 4, so it is 3.8 in that range. And you can say the median value for this value, it might lie over here. And see, if you want to see multiple subplots using like in the same figure, then we could use axis of 0 and axis of 1, where 0 and 1, and this indicates the row and the column. So basically now what I'm doing is I'm trying to fit in one bar plot and one pie chart, and in both these things, in one of the chart I want to see the student wording score, and in another pie chart I want to see how evenly my data is distributed, the pass and the false ratios. Okay, and see, you can see here that the same thing, almost whatever is there is stood, but we have used the student wording score distribution, as you can see the wording. And this is not clear because of I did not include the attached lines. I should have placed that, but we can see that similar to the content score, even in the wording score there are so many missing values over here. Well, I have concatenated the database, and I have to remove that using the drop or some other outlier treatment because the data is not evenly distributed. And in the passing grade I have kept it as the passing score as 50, so anyone who lies below 50 is comes as false category, and above 50 is the highest grade, is the true. So there are approximately 1649 students who have passed the exam, and I'm trying to show you a bar plot using the coloring. Like this displays the wording score and the data distribution for the bar plot, and this is a univariate bivariate analytics where two features are present. And in the statistical data analysis, we want to see the data distribution for the floating value numbers. And so for the mainly because I want for the content score, why I'm doing is wording score was for target 1, it was given first, and content score is the target 2. It is a developed version of the score, and based on this understanding, we can actually develop the model or decide if we have to clean the data, or if we should what kind of model could help us in dealing with undistributed imbalanced data. So in the content score, when the data is distributed, we see the frequency lies on the y-axis and the value lies on the x-axis. In the values, we see most of the values are lying between 1 and 0.5. So the negative 0.5 and the positive 0.5, there lies the mode and the median. So and it is an imbalanced bar chart. So histogram, it is an imbalanced histogram, and it is very asymmetric since most of the values are lying on the right, and the data is not evenly distributed like a mountain, but it is slopey, and we have fewer scores on the extreme right. They are not evenly distributed. So if we want to see the mean, median and mode, and also the max and the minimum value for the wording score data distribution, then these are the printed values. But you see words are easy to speak, but it is difficult to represent. So this kind of visual analytics, it represents easily. So this is the minimum value and this is the maximum value, that is the 4. And the yellow and the, you can see a light green line here and a yellow line which is combined. So yellow and green lines, you can see yellow and green lines that depict the median and the max value. No, sorry, orange line it is. Mean and median value, it is orange and green. Usually by mean, what do you mean is the central, it is a value which is calculated by seeing the data complete data distribution, and it is basically the total sum of the numbers divided by the number of data points which are present in the population. And by the median, you can see the central value, the center value which is present in the data distribution over the total population. So population, by population you mean the complete all the numbers which are present in the wording score, it is called as population. Whereas by sample, in a statistical sample, you mean some quantities of data or any random sample or any random data which is taken, which is picked randomly from the student wording score. And by the pink line, I guess it is the mode. Yeah, it is the mode value. Mode is basically a value which is a repetitive value, and it appears mostly in the distribution, and the repetitive value might be minus 1.5 or between minus 1.2 to 1 minus 1.9. And I also drawn the whisker plot because I wanted to see the quartiles and where is the median value, and what are the kind of outliers, or how is the data distributed. So the orange line in the box, it tells you about the median value, and the values which are present inside the box are very important, and they usually show you like most of the values are lying in this particular box, and you see it is lying between -1 and 1.5, and specifically there are other values as well which lie here in the extreme end, but they are scarcely distributed. And as you saw in the histogram plot, this is for wording score, right? Yeah, for wording score you can see it is reducing here and it is highly abundant here. So similarly, we have data, scarce data here. So it might be periodical data or data that appears very rarely or once in a season. So this is our first quartile and this is our second quartile, and the other wording scores lie between -1 to -2 and between 0.5 to 2.8. You can say maybe 2.4. And I wanted to write a data distribution like after going through all these graphs. Like if I give you the column value, then the function there shows the data distribution, and this is a data distribution function where it displays the mean, maximum, median, mode for a particular column, and also it displays histogram statistical lines. It plots the histograms where it sets the y label for frequency, and histogram is plotted based upon the frequency values. And also we are doing a box plot, and we are examining the variable, like we are giving the wording score as only again to show the distribution. You can see the data is distributed like this. It is similar to this graph, the wording score. And only I have changed the color of the lines here. I should have kept it same. And this is the box plot for the wording score. You have seen the box plot in a horizontal fashion, but this is a horizontal box plot, and this is the vertical box plot. So you can also rotate your box plots. Like vertical is equal to false, that's why it came out as horizontal. And I wanted to see the probability density function or the central tendency. So the central tendency value tells you how your data is distributed and how is it running. And usually in the Microsoft certification, it was they were using the grades for seeing the show density, but here I do not have categorical grade data, so I have utilized the wording score again, integer value, to see the data density. And the green and the orange, it usually shows the mean and the median. The mode can also be plotted as a vertical line. And this was my end of the book, and this is usually called as the probability density function, PDF, and it is very common. And usually PDFs they are iterated using pandas, and you can see iterative row data density for all the functions. So it is very important in time series data, and also while exploring the data to understand the data, so that we can decide what kind of predictive model can be used instead of going randomly for some XGBoost or LGBM. So that was the end of my video for today. Actually, this was yesterday's notebook, but I was working on the statistical data analysis because some of the functions it was not working well, and I thought I would be adding plotly plots because they are very famous and colorful and interactive, or some 3D interactive plots, but we do not have geographical location here, and I wanted to use plain numpy and pandas and matplotlib and sklearn. I wanted to keep it simple so that many people can understand the notebook. And also I've changed the title of my Kaggle notebook because this is a competition, and based on the upvotes and the number of people who see, people get medals like silver medal or bronze medal or gold medal. So silver and gold medal winners, they get a lot of interviews and competitions and money and cash from Kaggle. So sometimes if you win the competition or if you collaborate with others, then you get cash in very rare scenarios, but it happens. So if you get a chance, then you can click this icon here. This is called as upvote, and after you log in or sign into Kaggle, then you can upvote my notebook. Suppose if also you want to work on my notebook or copy and see how it runs, then when you do not get a edit sign here, but you get copy and share, you can click on that and you can edit the notebook. Edit the notebook and run the notebook, and also add many code features. So, and also do not forget to like and leave comments for this video. And if you want to see any specific data analysis like dashboarding or reporting or profiling or any time series data reporting or cloud data predictive modeling, then let me know in the comment section what is your favorite cloud repository like Azure, GCP or AWS, what kind of cloud environment are you working. Also let me know how are my videos as well. Leave positive feedback and negative feedback as well. I'm open to that as well. So bye bye, have a nice day, tata. Today చలో అయిపోయింది నా వీడియో ఇవాళకి ఇంకొక వీడియో తీస్తాను నేను మళ్ళీ.